On this question, we want to use the graph of y equals e to the x and the transformations to sketch the exponential function f of x equals negative e to the x plus 1 plus 2. Determine the domain and range, and also determine the y-intercept, and find the equation of the horizontal asymptote. The first thing we're going to start off with is sketching the graph of this basic function y equals e to the x. So I'm going to make a chart of x's and y's, and I'll use my standard set of x's, -2, -1, 0, 1, and 2. And we're going to substitute into the equation y equals e to the x. So let's start with the easy ones. E to the 1 is e, and that's approximately 2.718. Then we have e squared, and let's get a calculator out so that we can get some good approximations. We want to know what e squared is, and e squared is approximately 7.389. E to the 0 power will be 1. We can confirm that with a calculator. And we want to have e to the -1. And that's approximately 0.36. Let's use 8. And then e to the -2. Is 0.135. So this gives us some ordered pairs that we can use to graph the basic function e to the x. We have -2 and 0.135, -1 and 0.368, 0, 1, 1 and 2.7, 2 and 7.3. So we can see a sketch of this graph. Y equals e to the x looks like this. It has a horizontal asymptote that is right on top of the x-axis, the equation y equals 0. And that's because this piece of the graph right here will continue to get closer and closer to 0. You can see that these y values are getting closer to 0 without ever reaching it. So then we want to sketch the graph f of x equals -e to the x plus 1 plus 2. The basic graph is e to the x, and we have a few different transformations. We have the negative, the plus 1, and the plus 2. The negative is a vertical reflection. The plus 1 is a horizontal shift. And that's going to go to the left 1. And the plus 2 is a vertical shift going up 2. So we're going to take the points that we had on the graph of e to the x, and move them to their new position. So it's probably easiest to start with that point 0, 1. I think of that as sort of an anchor point of the graph because it's crossing through the y-axis. So from that position of 0, 1, we're going to shift to the left 1, would move to here. We're going to reflect vertically, so mirror over the x-axis, and then we're going to shift up 2. So you would get back to this point right here. Let's do that with 2 more points. I'm going to start with the point 1 and 2.7. We're going to shift to the left 1. We're going to mirror, reflect vertically, and then we'll shift up 2 and arrive at this position here. So it's a little bit hard to tell. I'm going to erase these intermediate points that I used. And let's use one more point. We'll start with this point here, -1 and 0.368. We're going to shift to the left 1. We're going to mirror over the x-axis and then shift up 2. And that would arrive here. So we've got these 3 points that seem to connect to each other, and it's a good idea to keep in mind where that horizontal asymptote might move to. The only one of these transformations that affects the horizontal asymptote is the vertical shift up 2. So the new horizontal asymptote will get shifted up 2 and will be the equation y equals 2. So now you can see that this portion of the graph will get closer to the horizontal asymptote, while this part of the graph will be mirrored. In the original graph, it was going towards infinity, and now in this reflected graph, it's going down to -infinity. So that graph in purple is the graph of f of x equal -e to the x plus 1 plus 2. It's also helpful to write the ordered pairs, the new ordered pairs. And I'm going to write a separate table this time for the x and the y, because the transformations affect both the x and the y values on this example. So let's highlight here. Using green, the transformations that affect the x are going to be the horizontal transformations. That's the one that shifted left 1. And in blue, I'll highlight the transformations that affect the y. The reflection, as well as shifting up 2, will be vertical transformations, and they affect the y-coordinate. So when we shift to the left 1, that affects the x-coordinate, and we're going to subtract 1 from the x's. So all of the x's will be subtracted by 1. So that makes -3, -2, -1, 0, and 1. For the y-coordinates, the reflection will make the y-coordinate opposite. So when you're above, you mirror to be below. So all of our y-coordinates get multiplied by a negative, and then the vertical shift will add 2 to it. So all of our y-coordinates will get multiplied by a negative, and then we'll add 2 to them. So I started with this y coordinate here, and I multiplied by a negative, and I added 2. And I'll do that for each y coordinate. And we can type these values into the calculator to get approximations, and they should match with the ordered pairs that we've drawn on the picture. I have negative e to the negative 2 plus 2 would be 1.86. Negative e to the negative 1 plus 2 is 1.63. And negative e to the 0 plus 2 is 1. Sorry, I meant to write those down before I did that. So we have about 1.9, 1.6, and 1. And let's do the others. That should be negative e to the 1 plus 2. And that is negative 0.7. Negative e squared plus 2 is negative 5.4. So those should match up with how we shifted the points or transformed the points using the graph. So now we want to determine the domain and range. The domain of every exponential function is all real numbers, negative infinity to infinity. And I'm going to use my ruler to determine the range. So we're looking at the graph in purple right now, the transformed graph, and you can see that the range will start at negative infinity, and it will continue until we get to that horizontal asymptote of 2. So we have a range of negative infinity to 2. We also need to determine the y-intercept as well as the horizontal asymptote. We already mentioned that the horizontal asymptote gets shifted to y equals 2. And in this table that we have here, we already have the y-intercept. But if you didn't have the y-intercept, you would substitute a 0 in for x to get it. So we have the y-intercept being 0 and negative 0.7. Thank you for checking out my videos. Have a great day.